Hello guys, Fru here. Welcome to today's presentation. So in today's presentation, we're going to look at this very interesting topic, the SMP versus the MPP. So if you work in the database world, you probably will come across this at some point in your career, right? SMP, which basically stands for symmetric multiprocessing, versus the MPP, which stands for the massive parallel processing. So these are two staples in the architecture world for data processing. Now, I'm going to dive into this. I'll talk about how and why they are different, and give some examples of companies or of databases that are either SMP based or MPP based. Now, if I'm assuming you're watching this video, you have some background in data systems, right? If you don't, I'm going to use a quick example here, just from a very rudimentary example to show us the importance of data systems. So assume that this is you, all right? Again, this is just very rudimentary to give us an example. You go out with a friend and you take some pictures, right? You take some pictures, right? I hope that kind of shows some pictures. You have some videos, right? How do you show videos, right? MP3. Yeah, so you have some video files and such, right? Now you come back to your PC, and this is your PC at home, and you upload your files to the PC, all right? Upload or download, you can use whatever term. Now, once you upload that file to the PC, what typically happens, right? The thing that people would always experience is, well, they say, well, I need to store the file on my PC. So I'm going to write the term store here. All right, you're storing the file on your PC. Now, where are you storing this file on your PC? Most PCs, personal computer, that's what I'm referring to as a PC, would have some storage drive, right? Whether you're using Mac or you're using Windows, there would be a storage drive somewhere on that PC, right? So this is where that file, that picture, or that video, or whatever it is you have available for you, gets stored on your PC. Now, if you open up your PC, you go to the file, you click on it, and then somewhere that image would display on the screen, right? And you can see that, right? If it's a video, it's going to show the video on the screen. So now, why am I showing this? I know this is very, very basic. This is not meant to be a video about, how computers work, right? I really want to talk about SMP and MPP, but I feel that, it's important to go back and just get some very fundamental. Again, this is so rudimentary that it's kind of funny that I'll put this here, but I did it nonetheless. So the three things that we see here are that the three concepts that are important here. One are the storage. So you need a space on every PC. This is true for every PC. You need a place. Let me write PC here. Personal computer. You need some form of storage, right? If your PC doesn't have storage, it's not going to work, right? You might have been in a situation where you have a lot of videos, a lot of files, and you try to load it to your PC and you get the error message that, well, you don't have space. There's no space on it. You need to delete something else to store that. So storage is number one, right? Number two thing is once you actually click on that file to look at it, all right, there is something that happens, and I'm just gonna call this compute. Some magic happens, right, where that file is read from wherever it's stored, right? So this might be on your D drive, your C drive, is read from the storage to the CPU or compute. And once it's been read from there, then you can actually see the file, right? So you're kind of going through these three layers, from storage to compute to presentation, which is what you actually see, right? So these are the three big phases. So if you really want to call these three phases, and this is true again for every PC out there, whether you're talking about a PC or even your mobile phone, a laptop, a desktop, it doesn't matter, right? You need a storage. If your computer doesn't have storage, it's not going to work. If it doesn't have a CPU or to process that data, it's not going to work. And in between, there is a need for memory, right, when you're doing your processing. And Again, I wouldn't go into the details of architecture here from basic of how the computer work, but just take it that these are the things that are needed, right? Storage, compute, which is your CPU, and then some memory, which is kind of like your intermediate store to store things. So just imagine that your friend tells you something, you can store it in your head, in your memory of your head, and if you want to keep it for a very long time, you can go write it on storage, right? So memory is just a short form place to remember things in computers, and if you want it to be stored for a long term, you write it on storage, which is sometimes you hear this called a disk, right? Within our computer system. So this is just a very simple example for us to kind of build the foundation of where we're going. So we need three things: storage, compute, and CPU. And for one individual, that works, right? That would work for you if you're just working on your PC and storing files. You can get away with this. Now, imagine companies or systems like Facebook, right? They don't have just one file. They have millions, if not billions or trillions of files, of pictures, of images, of videos that they need to store. You might have a file for an individual, maybe a 10 gig file. I remember the time when 10 gigabyte was huge, right? If I had a 10 gigabyte drive, that was huge. And if I upgrade to a 100 GB, right, that was huge. And even if you have a PC that's, some PCs would really want to convince you that they're big because they can sell you on 1 terabyte. That was huge for an individual. Now, if you're talking about Facebook, well, they're not talking about GB, they're not talking about gigabyte here or terabyte. These companies are talking about, a petabytes, right? PB, and even more zettabytes or whatever the big terms are. They have way, way, way more data than you can even imagine. So the question is, well, how do they manage to store that data within PCs when we know that notoriously PCs will just complain when your file is not even up to 1 terabyte? You can't even store it on the PC. Yet companies are having, petabytes of data, which is like tens of thousands of times of terabytes. How do they store that and be able to process it and analyze it in a way, right? So this would bring us into basically what the SMP architecture is and what the MPP architecture is. So I hope this kind of shows us the problem. Now, let's switch gears here for a second and take a look at closely at the SMP versus the MPP, the way it actually works within organizations. Now, so SMP, again, this stands for symmetric multiprocessing. Let me write that. Symmetric multi-processing, right? And MPP stands for massive parallel processing. All right, so what are the difference between these two? If you've heard of this term, what are the difference? So symmetric, the way the term stand is, some people will say simple multiprocessing, but it's really symmetric, is building on that idea that we just talked about, where if we simplify the PC we looked at and say, what does the PC need? A PC, a personal computer, it needs, some form of storage, right? So that's one. We know that if you have a computer, you need storage to store your file, your images, your video, or any form of data that you're working with. It also needs, this storage is sometimes called disk, right? So this is a disk for us. Now, it also needs some form of memory. I didn't mention memory earlier. So it also needs some form of memory. So this is like your short-term memory for processing. And then last but not least, it needs a CPU. And the CPU is a central processing unit. This is what actually processes that data. Now, most computers today, they have a core CPU. They have a CPU, and the CPU might have many cores, right? So you might have 1, 2, 3, all the way to like 8 cores or even more, right? But just think about that as a CPU unit, all right? And the way they do that is they would package all of this in a box, right? And we can call this a node, or we can just call this a computer, right? The term that you might use in the industry is a node. All right, so they'll package all of this in a node and they'll ship you this one box. So this is what the symmetric multiprocessing is. It's really thinking about it as, what do I need? I need storage, which is disk, right? So your C drive, your D drive, you know, from a personal perspective, but from an industrial perspective, for big companies, they're using way more robust storage here. And then they have a memory and they have a CPU. And then they package all of this, and this is the SMP. Now, let's look at the problems that we might find with the SMP architecture, something like this. So assume that your file is, you know, 1 GB, all right? And you can, you know, store 1 GB file on your storage, no problem, all right? Just like you can store 1 GB file on your laptop, no problem. What if that file is 1 terabyte? Okay, we can say, well, maybe the you know, machines or computers that can store, that have enough storage for 1 terabyte. So you just kind of make this box bigger. You just kind of increase this, right? All of this to accommodate for 1 terabyte file, and you just kind of make it bigger. All right. Now, what about 1 petabyte file? Can you store 1 petabyte on this box? All right, you could if you really try hard, right? And what you'll have to do is just keep making this single box bigger and extending that, all right? And then making the CPU big enough so it can also process that amount of data, because if you're making the box big, you're gonna have to make the CPU big as well, right? So you're kind of just expanding this box. So, and you have this 1 unit. So imagine you have a laptop that can store not just 1 petabyte, right? Think about 1,000 petabytes, or what comes after a petabyte, I'm not even sure. I know at some point there is something called a zettabyte, all right? And you can try to make this box as big as possible. But the problem when you do that is you run into certain limitations due to physics. All right, just by pure physics, you can only make a box so big for you to store data and be able to meaningfully query that. And so this is a limitation that, you know, this architecture where everything is kind of coupled into one box starts running into for us. And this is the problem with the symmetric multiprocessing. Now, I'll give some examples of when we talk about data systems in like the corporate world, the data systems or databases that use this architecture would be your typical databases, right? Say Postgres. I never know if you have a T there. SQL Server, right? Oracle, and a lot of databases are basically using this architecture. They would have one box, and if you want to make it bigger, you just try to make the box big, and you can only go so far before you run into problems. And that's where the MPP comes into play, because the MPP looked at this and realized that, well, there are limitations here. What if we have a different architecture that kind of achieves the same thing, allow us to scale out to accommodate more data, but without the limitations imposed by physics. All right? So let's define a little bit of physics. And the way they did that is, I think, is brilliant. And they said, all right, instead of just having one box that we want to try to make big and big and big and big, let's actually break it up so that we have many smaller boxes. All right? And you can have as many small boxes as possible, starting from 1, 2, 3, 3 all the way to n. All right, n boxes. So now within each of these small box, what is done is we give it, you know, a CPU, a memory, and a storage, right? CPU, memory, and storage. So each of those boxes would have a CPU, a memory, and a storage. CPU, memory, and storage for each of those boxes. So this is your CPU, memory, and disk, right? And that's our storage. And you just, you know, add this to all the boxes. And the beauty of this now is with this kind of architecture, each of these boxes are independent, are separate. So if you come in and say, well, you want to load a file, if you have a file that's 1 GB, all right, the box can say, all right, we're going to take your 1 GB file and we're going to put it here. All right, we're gonna put it on this disk, and if you come in and you try to access that file, we simply go here and we get it. We simply come to this box and we get it. So you come here and you get it. Now, what if that file is not just 1 GB? What if the file is 1 terabyte, all right, or even 1 petabyte? And we know 1 petabyte will not fit on one box, right? So what we're gonna have to do is we have to take that file, break it up into pieces, and then we store each piece on a piece of the node here, right? So we store some of the file here, we store some of that file here, and then we add as many machines as we need to eventually store all of that file. And as you can imagine, here you can add as many machines to accommodate as much files as you need to store, all right? And so here, even though we were, let me actually draw this, we were scaling, going up, right? Or they call it vertical scaling, vertical scale. Here we're scaling and we're going out, right? And they call this horizontal scale. So now we are looking at vertical scaling, and you might hear these terms in the data world where you're going up. I don't know if it shows up here, and vertical, and then horizontal scaling where you're going out. So at the very fundamental level, this is what the difference between SMP architecture and MPP architecture would be, all right? It really comes into play because of the limitations. We're trying to fit everything into one box and make it work. SQL Server, Oracle, DB2, maybe not DB2, but Postgres, and there are many MySQL even would be in here. That's a good one. MySQL. A lot of databases, if you work in the database world, will fall under this architecture. All right. But now on the MPP side, you have a lot of database too. You have like Exadata, which is from Oracle, because Oracle has their normal Oracle, but then they realize that, well, if you really want to scale, we can have an equivalent architecture for this, which is, they call it Exadata. Netiza is another one, which is using the MPP architecture, right? You have DB2, right? Another big one would be Teradata. And there are many more appliances, you might hear the terms appliances, that leverage this architecture versus this architecture. So if you're working at a company and you know somebody says, well, we have we're doing MPP architecture, and or we have an appliance, you can start thinking that, all right, this is kind of what is happening underneath the scenes, right? And the beauty of this is it can turn to store a lot more data, right? More data versus this, where sure you can get a lot of data, but at some point you would hit limitations that the system just will not be able to perform and solve for you. And so this kind of gives you some ability to scale horizontally, because you can keep adding nodes. As I don't think you can do it infinitely, because again, you're gonna have to deal with more physics problems in there of networking and things like that. But that's a whole separate video in itself I can talk about. But hopefully this kind of gives you that overview idea of that. Now, the question might be when and why, or what are some of the use cases where this would make sense, the SMP versus the MPP, right? And we can talk a lot about that. SMP would be great for, let me use a different color. This would be great for OLED TP, and typically this is great for OLAP, right? And by OLED TP, what I'm referring to there is online transactional processing systems. So if you go to a store and you buy something, and that store is writing that information, that transaction to a database, right? Transaction, the T there, that's a transaction. Very quick read, write. You can quickly put that into the systems, and this kind of databases will work, all right? MySQL and all of that would work. But if you have thousands and thousands of databases and you want to create a data warehouse for analytics, for queries and things like that, if you hear of a company having a data warehouse, usually they look for MPP systems. They look to MPP systems to solve that problem and to meet that needs, right? And that's why you might hear of a company having a data warehouse, which is Teradata or Exadata or Netiza, all right, or DB2 from IBM, and there are a lot more of this. The cloud versions of this are interesting. You might hear Redshift, and there are other databases that are in the cloud that are using this architecture, but it all boils down to solving the problem of storing data and providing the necessary compute for it. Now, there are limitations as well, even with this MPP architecture, because, like I mentioned, a lot of companies, these companies that deliver this, would deliver them in form of an appliance, right? And what I mean by appliance is, you can imagine, if we step back to say, how does this all work? It works because you can take one machine, one computer here, connect it to another computer that has a disk memory storage, and just kind of connect them more and more to kind of get the MPP result. But the problem is, to do that efficiently in a way that works, it's very tricky. So what the companies will do is they will build all of this together, package it up, right? They might put, say, they'll give you an appliance with like 50 nodes, 50 N. So it has 50 of these small computers in there, and they just ship it to you off the box, right? Like all ready to go. All you need to do is take that, connect to the power wall, and start using. All right, so this is called the appliance, the MPP appliance. Here in this site is usually software. They give you software like MySQL software, and you install it on whatever server you want. You know, that works here. But in this case, because you're talking about many different servers, and you want to make sure the performance of all of them are the same, right? Because you don't want a good server here and a server here that's broken, and it could really cause problems. So they ship this to you or to companies in the form of an appliance. But the appliance starts coming with its own problems, because what if you need more than 50, you need more than that, right? You have to keep buying that appliance. It's expensive. Plus, the second issue might be, what if in your situation, you don't want to have more memory, you just want to have more storage, all right? Well, each time they ship you an appliance, they are giving you disk and storage, right? They're giving you storage and CPU combined. They have to send it to you, all right? So you have to buy that. But if you just wanted to store data without necessarily analyzing that data, OLAP, then that becomes a problem, because you're paying for something that you're not using, all right? And what if you wanted to compute more and you don't necessarily need storage? Well, you still get the storage regardless, because each time they add this, they have to add the memory, the CPU and the storage by force. You don't have an option. And so this really was a problem, or is a problem for some organizations that are looking at this architecture. There are other architectures that are coming up that are new, brand new. One of them is what a company called Snowflake does. They have an architecture that really separates storage from compute, and that could be a separate. I think I have videos on my channel around Snowflake, so check that out if you want to see the architecture for, again, storing data and processing data that completely separates storage from compute. And if you have any questions, I can make a follow-up video around that. But hopefully this gives us just a warm introduction of the difference between SMP and the MPP architecture for data storage and for data systems. So to summarize this, SMP, the symmetric multiprocessing. The MPP on the right side here is the massive parallel processing. So that will be the very high level. On the left side here, one of the things that you might hear, or if you hear about shared OR architecture, that's kind of common, because here you're sharing everything. You're sharing disk, you're sharing memory, and you're sharing CPU, right? On this side, you might hear people say shared nothing architecture. I think I should show that. So shared all, shared nothing, right? Because here you're sharing CPU, memory, and disk. In this side, each of these individual nodes is an independent piece. The data here is different from the data here, right? The CPU here is different from the CPU here. This CPU is not going to come take data from here. I mean, there are ways to do that, shuffling and things like that, but that's a little bit more advanced. But if you think about it, the data from here is separate from the data from here. So it's actually sharing nothing. So shared all, shared nothing. And then if you go into more details here, this one usually requires a lot of networking and some more babysitting and advanced work to get it. But if you get it working, you can really do a lot with this. All right. But this one, you can just, you're ready to go, right? I can get my laptop and make this work, all right, even though it would be at a smaller scale. And last but not least, you might hear the term appliances, which will apply here. And then in here, it's mostly just software. You're not dealing with appliances, which is hardware. All right, usually in here, the software comes with the hardware. So Exadata or Teradata or Netezza, in particular, Netezza will ship you a box with the software made to work on that hardware. You're not gonna take that software and go run it on some other place. I don't even think that's possible. So you have to use the hardware. Whereas here, pure software. All right, guys. So I hope this was helpful. We have seen the differences between SMP and MPP architecture. If you work with data, sometime or another, sooner or later, you come across these two terms. Hopefully, this has shed some light for us. Like I said, there are more newer emerging architectures built for the cloud. Something like Snowflake is number one, I would say, and I have separate videos on that. But if you have any questions, I can always make a follow-up video. Thanks for watching. Share this with somebody that might get value out of this. Subscribe if you haven't, and if you have a question you want me to maybe break down, make a video on, don't hesitate to let me know in the comment section below. I'll be more than happy to share a thought or two about that. This has been Fro. Thanks for watching. I'll see you next time.